Free fall. So free fall is when something falls in vacuum, meaning no air resistance, not any kind of resistance. The only force and the only acceleration we have is because of gravity. The acceleration due to gravity on Earth is pretty much 9.8 meters per second squared. It actually changes from 9.79 to the equator up to 9.84 to the poles. So the average is considered to be 9.81. We round it to 9.8, and we very often round it to 10 meters per second squared, so we make our life easier. The negative sign shows that the negative sign is used when we consider the upwards motion to be the positive and the downwards motion to be the negative. If for some reason, and very often this happens, in problems we don't care about upwards motion because we only have downwards motion, then we can easily consider that to be positive, and we can consider G to be 9.8 and make our life easier. So in this case, the acceleration is 9.8. It doesn't change for small heights. For heights of 500 meters, the G will be 9.8. So velocity changes by negative 9.8. I have here two cases of how position can change. Not the position is the same. The difference is how we consider it. And what do I mean? Okay, so let's say that we have an object that falls from a height of 50 meters above the ground. So we can consider that height to be the zero, and then the ground will be at negative 50 meters, or we can consider the ground to be the zero, and then that position will be positive 50 meters because it's 50 meters above the ground. So I'm starting with the second case, considering that the ground is at zero and the initial position is considered to be the positive 50 meters. So in this case, we see that we need to subtract the position. The position gets less and less until it reaches the ground. If I consider my initial position to be 0 and the ground being at negative 5, all positions and all displacement will be negative. There is no difference on that. If you are going to see that if you add them up, they always give you a 50. That means that there's no difference. It depends only on the students which case they consider as being the easiest one. So for my graphs, I considered that the ground is 0 and my initial position is 50 meters above the ground. So in this case, we see that the acceleration time graph is a constant, negative 9.8. The velocity increases from 0 with negative values. The object speeds up downwards, and starting from 50 meters, going down, it reaches the ground a little after 3 seconds. Another thing that you need to see is that, again, just because this is an accelerated motion starting from initial velocity 0, the displacement again follows the rule that for double time the displacement is 2 squared. That means 4 times higher, and for time 3 times higher, the displacement becomes 9 times bigger. The equations are exactly the same. What I did, instead of writing the normal acceleration A, I used the letter G, which is the symbol for the acceleration due to gravity. The formulas are the same. Now, in most of the cases, the initial velocity is 0. And very often, we will consider the initial position as 0. In these cases, the equations we have are simplified to the ones that are beneath. So the velocity will be found by just multiplying the acceleration due to gravity with time, and the height will be only the term that has the acceleration half gt squared.